Hello, hello, all my beautiful people. Welcome to the wonderful world of pre-calc. We are looking at section 1.5 today, which is all about combinations of functions. So we're just going to get right on into it. Three objectives for today. The first one is we're going to be looking at how to add, subtract, multiply, and divide functions. So how do I add them together, right? How do I subtract them, multiply them, and divide them? Okay, so that should be fairly review, right? At least the first three, maybe not divide, but at least the first three. Then we're going to find the composition of functions. Composition. S plural, there we go. Find the compositions of one function with another function. So all I'm doing is I'm taking one function and I'm plugging it into another function. And then we're going to use those compositions to model and solve real world problems. So the first thing that we want to look at here is just the sum, difference, product, and quotient, like the different rules here. Okay, so if I have f plus g of x, we just know that it's the same thing as the f of x plus g of x. So I have two functions, and I just add them together. And that gives me, right, if I have f of x and I have g of x, I just add them together. Same thing with subtraction. The only thing is you have to make sure that you distribute this negative into this second function. Multiplication, we're just multiplying two functions together. And then division, we're just dividing two functions. However, this is really important right here, right? When we're dividing, whatever is on bottom cannot be 0. So as long as we're paying attention to that. So we're just going to jump right into it. I think that you'll find that this section isn't too terrible here. Hopefully that's the goal. Okay, so let's look at example 1. Given that f of x is 2x plus 1 and g of x is x squared plus 2x minus 1, find f plus g of x. Well, just know, like what it just said up above, that's the same thing as f of x plus g of x. So I'm just going to take my f function, which is 2x plus 1, and I'm going to add my g function, which is x squared plus 2x minus 1. And then I'm going to combine like terms, so I have an x squared plus 4x, and then the 1's cancel. And that's it. So f plus g of x is equal to x squared plus 4x. And that's it. Okay, so there's my answer there. And then part B wants me to find f plus g of 2. Well, I already know what f plus g of x is, right? So f plus g of x, we just solved was x squared plus 4x, right? We just did it right here. So then if I want to find f plus g of 2, I'm just going to plug in 2. So I have 2 squared plus 4 times 2, which gives me 4 plus 8, which is 12. So that tells me that f plus g of 2 is 12. Shouldn't be too bad there. Hopefully that makes sense. I want you guys to give this one a try and just do this one real quick, and then when you feel ready, go ahead and hit play on the video, and we'll go over it. All right, so we have f of x plus g of x. Well, my f of x here is x squared, plus my g of x is 1 minus x. Okay, but if I want to write that in the proper way, right, in the correct order, I have f plus g of x equals x squared minus x plus 1. So there's the first part. Oops, I found f plus g of x. Now I want to know what is f plus g of -1. So I'm just going to plug in -1. So -1 squared minus -1 plus 1. Be careful with the double negative there, right? -1 squared is 1. Double negative gives me 1 plus 1. So f plus g of -1 is 3. Boom, look at that. Easy peasy, hopefully that's making sense here. So we're just gonna keep on cruising, right? Now let's look at finding the difference, right? Subtraction. It's the same thing, right? Whatever's written first, which is in this case my f, minus whatever's written second, which in this case is g. Make sure you pay attention to the order here because g minus f of x would have a different answer. So make sure that you're paying attention to what it's asking you to find, okay? The only difference here is that you have to subtract, so you have to distribute that negative, okay? So I have f of x, which is 2x plus 1, minus, and I'm going to put my g of x in parentheses, and my g of x is x squared plus 2x minus 1. So literally the only difference is that I have to distribute this negative to get me negative x squared minus 2x plus 1. So that tells me that f minus g of x is equal to, well, I have negative x squared. 2x minus 2x cancels, and then 1 plus 1 is 2. So negative x squared plus 2. That's our answer. And this kind of looks like a 3, so let's make sure that that's an x squared. There we go. Okay, now I want f minus g of 2. So f minus g of 2. Well, I already found what f minus g was, so I can just plug it in. Be very careful. This negative is outside the parentheses. Okay, so 2 squared is 4, but then it becomes negative 4 because this negative just comes straight down. So I have negative 4 plus 2. So my final answer is f minus g of 2 equals negative 2. Boom. Go ahead and hit pause on the video, try the extra example, and then when you're ready, we'll go over it. All right, so again, I looked at my order and I see that the f function is first. So I'm going to write my f function first, which is x squared, minus, and then my g function is in parentheses. So whatever that second function is always has to be in parentheses, okay? And then I get x squared plus, oh, excuse me. I was skipping steps. It's going right for the plus x. Okay, minus 1 plus x. So then if I write it in the correct order, f minus g of x is equal to x squared plus x minus 1. So there's that function. And then I want to evaluate where at negative 1. So f minus g of negative 1 equals, and I just get to plug it in. So negative 1 squared plus negative 1 minus 1. Negative 1 squared is 1. Then I have minus 1. Then I have another minus 1. So f minus g of negative 1 equals negative 1. So again, if you missed that or if you made a little mistake somewhere or whatever, just make sure that you fix it as we go so that your notes are correct, okay? And we're going to move on to the product. Product is just multiplying. Guess what? It's the same thing, right? This is f times g of x is the same thing as f of x times g of x. And for multiplying, the order doesn't matter. So even if the G was written first, you would still get the same answer. But for subtraction, you would have to pay attention to the order. Okay, so here I have f times g of x, which is f of x, which is x squared, times g of x, which is x minus 3. And I distribute, so x squared times x is x to the third, and x squared times negative 3 is negative 3x squared. So f times g of x is equal to x cubed minus 3x squared. So there's that. And then I want to evaluate at 4. So I'm just going to plug in 4 since I already found f times g. So I get 4 to the third minus 3 times 4 squared. Okay, 4 to the third is 64. Minus 3 times 4 squared is 16. So I get 64 minus 3 times 16 is 48. So f times g of x equals to 16. Oh, and not of x, excuse me, of 4. Right, if I plug in 4, I get out 16. All right, we got another try it here. There's some fraction work, but you guys can do it. I believe in you. Okay, go ahead and give this a try. I'd rather you try it and mess up and have to erase it and redo it than not try it at all. So make sure you try it. Hit pause on the video, and I'll see you in a second. Okay, so the first thing I see is that this word is wrong. This should be product, right? Because I'm multiplying. So sorry about that. Let's go ahead and change that. Okay, now I have g of f of x. So I'm going to multiply. Well, first I'm going to write it. Right? And I'm going to take my g function, which is x over x plus 1, and I'm going to multiply it by my f function, which is 1 over x. Okay, when I multiply these together, I get x over x times x plus 1. My x's here get to cancel, so I just get 1 over x plus 1. So g times f of x is equal 1 over x plus 1. However, there's one value, there's actually two values that x cannot be. Okay, the first value I see that x cannot be is negative 1. And the reason for that is because if I plug in negative 1 here, I would get negative 1 plus 1, which is 0. And you cannot have 0 on the bottom of a fraction. Okay, the other value that I see that I cannot have is 0. And that is because of this function right here. If I have 0, if x is 0, then I would get 1 over 0, and I can't have that either. Okay, so boom. So if there are restrictions on what x can be, you have to make sure that you write that. Okay, and then the last part here is g of f of negative 3. And so I'm just going to plug it in. I have 1 over negative 3 plus 1. So g times f of negative 3 equals negative 1 half. Right, negative 3 plus 1 is negative 2. I just moved the negative to the top, but it doesn't matter. Okay, hopefully we're feeling pretty good on adding, subtracting, and multiplying. Now we're going to look at dividing, and dividing is a little bit different only because we have to worry about the domain. right? I can't have 0 on the bottom of the fraction. Sorry, I thought I was going to sneeze. Okay. We can't have 0 on the bottom of a fraction, so that's going to make a really big difference here, okay? So, here in example 4, we have f of x equals the square root of x, and g of x equals the square root of 4 minus x squared. So the first thing they want us to do is find f divided by g of x. So this tells me the f is on top, so let's write this correctly, shall we? Yes. So f over g of x equals, it tells me f is on top, so square root of x is on top. And then on the bottom is square root of 4 minus x squared. Okay, so that's f divided by g. Now I want the domain of this, right? The domain of f divided by g. Now, remember that domain is any number that you can plug into the function, okay? So what happens now is that we have to look at the domain of the top, and we have to look at the domain of the bottom, and we have to kind of combine those two to make something that works for both. Has to work for both the top and the bottom, okay? So let's just focus on the top first. I'm going to make little notes down here. Square root of x. The domain of square root of x, because it's on the top, it can be 0, right? Because you can have 0 on the top. So the domain here is anything greater than or equal to 0. The only thing I can't have under the square root is negative. Okay, so x is greater than or equal to 0. No problem. Perfect. Way to go, right? Anything bigger than 0. But the question is, does that work down here too? Okay, so let's look down here at the bottom when I have 4 minus x squared. Well, I know that whatever's inside the square root here, which in this case is 4 minus x squared, it has to be greater than 0. And I know it has to be greater than 0 because I have a square root and you can't have negatives. And I know it can't equal 0 because the square root of 0 is 0, and you can't have 0 on the bottom of the fraction. So I'm going to go ahead and solve this, if that's cool with you guys. I'm going to add that x squared to the other side, just for the sake of keeping everything positive. Square root, and I get x is greater than plus or minus 2. And then you're like, what? What the heck does that mean? X is less than plus or minus 2. What that means is that x is between negative 2 and positive 2. Okay, so any number between negative 2 and positive 2, I'm allowed to plug in here. So now I have to look at these two domains and say, where do they cross over, right? Where are they both valid? Here, it's any number greater than or equal to 0. Here, it's numbers between negative 2 and 2. So the question is, what's the smallest number I'm allowed to have? And hopefully, you said 0. Sorry, I just got real distracted for a second here. Okay, hopefully you said 0. Because 0 works here, right? I can have it here. And 0 works here because 0 is between negative 2 and 2. So 0 with a bracket. And then we have to ask ourselves, what's the biggest number I'm allowed to have? Here, this goes to infinity, but this stops at 2. So 2 is actually the biggest number I can have. And because there's no equal to, it's a parenthesis. Okay, so that is my domain of f over g of x. Ooh, almost erased the whole thing. Don't want to do that. Okay, so let's look at the next one, which is g of f of x. So now I want g over f of x. So now the g is on top, so I have the square root of 4 minus x squared on top and square root of x on bottom. So there's writing the function. Now I want the domain, right? So again, we're going to look at the top, square root of 4 minus x squared. Now the top can be 0. So 4 minus x squared can be greater than or equal to 0 here. So I get 4 is greater than or equal to x squared. So I get plus or minus 2 is greater than or equal to x. So again, it's the same thing. It's negative 2 is less than or equal to x is less than or equal to 2. So there's the domain for the top. The only difference is that I have or equal to's because the top is allowed to be 0. And the next one is square root of x. And the domain here is just x is greater than 0 because I cannot have 0. Okay, so then the question is, what's the smallest number I can have? And hopefully your answer was 0, right? But it's 0 with a parenthesis because I can't actually have 0. If I have 0, I get 0 here, and that's no good. Okay? And then what's the biggest number I'm allowed to have? Well, again, it's 2, but this time it's a bracket. So hopefully that makes sense. You just have to take the two domains and try to overlap them and see where they overlap, and then that is the domain for the whole problem. So I want you to try this last example, the extra example. Give it a good old college try, and then when you are ready, go ahead and hit play, and we'll go over it. Hopefully you gave this a try here. So we have f is over g, so that's really important to note, is that in this problem, the f is going to be on top, and the g is going to be on bottom. Okay, so my f of x is x squared, my g of x is 1 minus x. So that part should be really quick. Now, the domain, okay, so I need to find the domain of x squared, which hopefully we know is all real numbers. I also have to find the domain of 1 minus x, which again is all real numbers. However, because it's on the bottom of a fraction, I can't have 0, so x cannot be 1 because the value of 1 would get me 0. Okay, so then I need to look and I need to combine these two, right? I need to figure out what works for both. Okay, so in this case, it's not as tricky as the one up above. Okay, x is in the set of all real numbers, but because all real numbers works for both the top and the bottom, but x cannot equal 1. Okay, there are other ways that you could write it, right? You could do it in interval notation and say x cannot equal 1. That would be okay as well. But this is the one that really makes the most sense here. Okay, so hopefully we're feeling good about adding, subtracting, multiplying, dividing fractions. Or functions, excuse me. If we are not, please make sure that you reach out to me and or your teacher and let me know and get some help, okay? So we're going to move on to composition. Now, composition is kind of fun because what we're doing is we're taking two functions and we're taking one function and we're plugging it in to the other function. Okay, so the composition of f with g, so here's my notation, right? It has this little open circle. So we could say f of g, or this is another way, right, that you could say it, right? F with g of x, and then, or you could say it here, f with g of x. Okay, and then the domain, the domain is f with g. We have to look first at any numbers that work for g. So whichever one is on the inside. Okay, so we have to look at this domain first, g of x. Any values that work in g of x that also will work in f. will be part of our domain. And so hopefully as we look at it, it'll make a little bit more sense. But let's just look at example 5 here and see what we can come up with. Okay, here I want to find f with g of x. For f of x equals the square root of x, right? And x has to be greater than or equal to 0 because of square root of x. And g of x is equal to x minus 1. Okay, and x is greater than or equal to 1. If possible, find the value at 2 and again at 0. So the trick here is to start inside and work out. Maybe outward. Start inside and work outward, meaning whatever function is written most on the inside, that's what you're going to look at first. Okay, so f with g of x means I'm going to take my g of x and I'm going to plug it into f. So this is the same thing as f of g of x. I'm taking whatever my g of x function is and I'm plugging it, I'm plugging it into f. Okay, well g of x in this case is x minus 1. So this is really f of x minus 1, right? So I took my g of x function and I plugged it in right there to get f of x minus 1. Okay? Now this means in the f function, whenever I see an x minus 1, whenever I see an x in my f function, I'm going to change it to x minus 1. So here I get the square root of, instead of x, it's x minus 1. Okay? So now I have to ask myself, what is the domain? Well, the domain here, and I have to look at g of x first. The domain of g of x is anything greater than or equal to 1. Okay? And the domain of f of x is 0. So if I combine those two, right, if I were to like stack them on top of each other, where would the common ground be? Where would both functions work? And the answer would be anything greater than or equal to 1. So that's my domain. Now, if I want f with g of 2, I already know what f with g is, so I can just plug in 2 minus 1, which is the square root of 1, which is 1. And then I want f with g of 0. And hopefully the first thing that we notice is that 0 is not part of the domain. So this is very likely, this is not going to work out for us, but I'll show you why. Okay, so if I plug in 0, I get 0 minus 1, which is the square root of negative 1, which is I, right? And so this is not possible. We're not allowed to have that right now. We already knew that 0 wasn't going to work because it's not part of the domain. But just to show you anyway. Okay. All right, so I want you guys to try this one. Again, it's better to try it and mess up and then not to try it at all. Okay, I'd rather you mess up and have to erase the whole thing and redo it and at least try it. So here's the extra example. Go ahead and hit pause on the video, and then when you are ready, hit play. Okay, so here we have f with g of x. So again, the g of x is on the inside. So that means I'm going to take my g of x, and I'm going to plug it in to the f function. So this gives me 1 over, and instead of x, it's going to be 2x plus 1. Okay, now again, I have to find my domain. So right now I'm looking at that my domain is, and let's write it correctly, shall we? X is in the set of all real numbers, but x cannot equal, and then the question is what value here would give me 0? And hopefully we found that it was negative 1/2, right? If I plug in negative 1/2 into x, I would get 0 on the bottom of the fraction. So I can have anything I want except for negative 1/2. So then it wants me to find f with g of negative 1. So I'm just going to plug in negative 1. So 2 times negative 1 plus 1 gives me 1 over negative 2 plus 1, which is negative 1/2. Oh, oh, math. That's really funny. I was like, that's not right. I get negative 1 over 1, which is negative 1. There we go. And then f with g of negative 1/2. Hopefully we already see that this is not going to work because I'm not allowed to have negative 1/2. Well, let's try it anyway. I have 2 times negative 1/2 plus 1. Gets me 1 over negative 1 plus 1, which is 1 over 0, which is undefined. We're not allowed to have that. So again, just to prove that I cannot have this negative 1/2. Okay, we're going to keep practicing with some compositions, but hopefully that makes sense, right? Whatever's on the inside, right? Whatever's on the inside, that will be the function that we plug into the one on the outside. So for example, if this was written the other way, if this was g with f of x, that means I would take my f of x and plug it in here. So that would be 2 times 1 over x plus 1. And you get a totally different function, right? Here I have 2 over x plus 1, which is totally different than what we had before. So just make sure that you pay attention to the order. Alrighty, example 6. Given that f of x is x plus 2 and g of x is 4 minus x squared, find the following. Okie dokie, here I have f with g, so that means I'm taking g and I'm plugging it into f. So actually, let's do that work up here. So we have room, okay? So f with g of x equals, I'm going to take my g, draw it up here too, and I'm going to plug it in to my f. So I have 4 minus x squared plus 2. And if I simplify this, I get negative x squared plus 6. Okay, then it wants me to find the values at 0, 1, 2, and 3. So f with g of 0 means I have negative 0 squared plus 6, which just gets me 6. F with g of 1 is negative 1 squared plus 6, which gets me 5, right? Negative 1 plus 6. F with g of 2, negative 2 squared plus 6, which gets me 2. And then f with g of 3 is negative 3 squared plus 6, which is negative 3. And that's it. That's all we're looking for here. So hopefully we're not feeling too overwhelmed. For part B, notice it's the other way, right? G with f. So that means I'm taking my f and I'm plugging it in for g. So this gets me 4 minus, and then instead of x squared, it's x plus 2 squared. Remember that x plus 2 squared is not x squared plus 4. You have to write it twice, boom, boom, and then distribute. Okay, so if I just do that in my head, because I know how to do it, x squared plus 4x plus 4. So my final equation here is negative x squared minus 4x. And then actually the 4 and then the negative 4 cancel. So it's just negative x squared minus 4x. And then I'm going to do the same thing. G with f of x. Oops, this is a 0. There we go. Is negative 0 squared minus 4 times 0. So I just get 0. G with f of 1 is negative 1 squared minus 4 times 1. Okay, so that's negative 1 minus 4, which is negative 5. G with f of 2, negative 2 squared minus 4 times 2. So this is negative 4 minus 8, which is negative 12. And then last, but certainly not least, we're looking at the value at 3. So we have negative 3 squared minus 4 times 3. So negative 9 minus 12 is negative 21. Boom! Mic drop, right? We are almost done. We have about a page and a half left. We're cruising. Let's keep moving on. Again, make sure that you are reaching out if you need help on any of this, okay? Okay, rules for excluding numbers from the domain. I kind of already talked about this, but what we're looking at is if, first of all, notice that in this example, the G is on the inside. So all these will switch if the F is on the inside, okay? But the idea is the same. Whatever is on the inside, if the number is not in the domain of this inside function of g of x, so if x is not in the domain of g, it can't be in the domain of the whole thing. Okay, so you have to start with the domain of g, right? Then any numbers that work for g but don't also work for f are also not in the domain. So you have to find, again, you have to find both, right? You have to find g first, and then any numbers that don't work or that do work in G but don't work in F, you also have to take out. So I think it's easier if we just look here. Okay, so here I have f of x and g of x, and I want to find the composition. So the G, right, this guy is going in for F. So F with G of x equals, instead of x squared, it's the square root of 9 minus x squared minus 9. So hopefully that makes sense. A square root and a square get to cancel, so that's exciting. So I have 9 minus x squared minus 9, and 9 minus 9 also cancels. So I just get negative x squared. So f with g of x is just negative x squared. Okay, now I want to find the domain. So the first thing I have to find is the domain of g. Okay, and the equation here for g, and I'm going to erase this now so we can look at g fully. Looking at g, I cannot have a negative under the square root. I can have anything from 0 or bigger, but no negative, right? So 9 minus x squared has to be greater than or equal to 0 because I cannot have any negative numbers under a square root. So if I solve this, I get 9 is greater than or equal to x squared, square root, and I get plus or minus 3 is greater than or equal to x. And then hopefully we looked at this earlier, but this just means -3 is less than or equal to x is less than or equal to 3. Or you can write it as 3 to 3. Either way. Okay, great. So the only numbers that work for g are any numbers between -3 and 3. Okay, good? Yes, okay. The only numbers that work for g are between -3 and 3. Now I have to say, are there any numbers between -3, sorry, I didn't write the negative, -3 and 3 that don't work for f? Okay, that don't work for plugging it into f. And the answer is no, because I can plug any number I want into f. The domain of f is all real numbers, okay? So then that tells me that the domain of f with g of x is just -3 to 3. If this was a square root, or if this was a fraction where 1 wouldn't work or something like that, then you would have to take out that number as well, okay? But since I can plug in any number from -3 to 3 into f of x, then this is just my domain. So hopefully that makes sense. It's a little tricky. I think we have some more examples here. Yes, we do. Okay, so let's try another one. And I guess this one doesn't have domain range, but that's okay. All right. What I want you guys to do is I want you to actually find these two, and you're going to do it on your own, okay? So go ahead and hit pause on this video, and I want you to find f with g, and then I want you to find g with f, and something special happens here. So go ahead and give it a shot, and then when you're ready, hit play. Alrighty, so check your work here, make sure everything looks good. I plug g into f in this first one, and I multiply the 2 times 1/2, which just gets me 1. So I'm left with x minus 3 plus 3, and the 3's cancel, and I get x. And then over here on b, I plugged the 2x plus 3 into x, so the 3's can cancel, and then I get 1/2 times 2x, which is x. And hopefully if we remember back, when you do this, when you plug one function into the other and then the first function into the second, right, in both ways, if you get x both times, it means that these functions are inverses of each other, which we will talk more about in the next video, but just as a little hint, okay? So we can say, therefore, you haven't seen this symbol before. That's what it means. The 3 dots in a triangle means therefore. So you'll see that used a lot, okay? So therefore, f of x and g of x are inverses of each other. Okay, so they're inverses of each other. Woohoo, super exciting. Again, we will talk about that more in the next video. All right, we're getting close, guys. Now we're just looking at identifying a composite function, meaning if I'm given the composition, can I split it up, right? Can I split it into those two original functions? Meaning here's h of x. Can you tell me what f of x and what g of x was in order for this to work, in order for us to get this? So what I kind of look at are big pieces here. One, I see the 3x minus 5 as a big piece because it's in parentheses. And then the other thing I see here is this cube as a big piece. So I'm just going to split those up. If I want f with g, let's just say, it doesn't say exactly, but let's just go. That means I'm going to take g and I'm going to plug it in for f. Okay, well, if g is 3x minus 5, and I'm going to take that and I'm going to plug it into f. To get this, f would have to be x cubed, right? Because then I take this, I take my 3x minus 5 and I plug it into x cubed, and I would get 3x minus 5 cubed, which is what I have. So all we're doing here is we're moving backwards, okay? And there are multiple ways that you can do this, so don't stress about it too much. All we're doing is splitting the function, okay, into 2. So here for b, if I want f of x and g of x, again, let's assume that we're putting g into f. Okay, I see a couple big pieces. I see my x minus 2 because it's in parentheses, and then I see 1 over x squared. So if I have g of x as x minus 2, then f of x can be 1 over x squared. And I would take this and I would plug it in and I would get what I started with. Again, there were other options as well. So if you saw something different, totally fine, right? You could have had f of x is 1 over x, and then g of x could be x minus 2 squared. And that would also work, right? Because if I take this and plug it in, I would get that. Okay, so there are other options here. I'm just trying to show you the simplest one. And last but not least, we just have an application problem, like how do we use this in the real world? So let's read this problem and see what we can do with it. The number n of bacteria in a refrigerated food is given by this equation n of t, where t is between 2 and 14, because T is the temperature of food in Celsius. So that means the lowest T can be is 2 degrees Celsius and the highest T can be is 14 degrees Celsius. When the food is moved from the refrigerator, the temperature of the food is given by T of T, right? So lowercase t is time in hours. So we're talking about what's the temperature of the food between 0 hours and 3 hours. So the first thing that they want is the composition of n of t and interpret its meaning. So I'm going to have to write real small here, so wish me luck. N of t, which means I am taking t of t, which is this, and I am plugging it into n. So there and there. Okay, so I have 20 times, instead of t squared, it's going to be 4t plus 2 squared minus 80 times 4t plus 2 plus 500. And I'm going to keep going because, right, we have to simplify this as much as possible. So I have 20 times 4t plus 2 squared. Remember, you have to write it twice, right? 4t plus 2 times 4t plus 2. And I get 16t squared plus 16t plus 4. And then I'm going to go ahead and distribute this 80. So I have minus 320t minus 160 plus 500. And then lastly, let's go ahead and distribute this 20. Wow, I couldn't think of the word 20. So I get 320 t squared plus 320 t plus 80 minus 320 t And then I'm going to go ahead and, well, no, let's just leave it. Let's just do it all at once. Minus 160 plus 500. So a lot of like terms here, but I do have a 320t that cancels with a 320t. So that's neat. So I get 320 t squared, and then 80 minus 160 plus 500 is 420. Okay, so I found the composition. Now the question is, what does this mean, right? Who cares if you don't know what it means? This equation was the temperature of the food, right? T of T was the temperature of the food. N of T was the amount of bacteria. Okay, so when I combine those together, I get the number of bacteria in terms of, and then what is the variable? The variable is lowercase t, and lowercase t is time. So in terms of time in hours, the food has been out of the fridge. Has out of the fridge. Okay, so this now tells us if I knew the temperature, right, then this function is based off temperature, and it's the number of bacteria. So I can figure out how much bacteria there is on the food given the amount of time it's been out of the fridge. So then here, for B, it says find the number of bacteria in the food when T is 2 hours. Well, that should be pretty easy, right? I want N of T of 2. So I want the temperature of the food after 2 hours. Once I know the temperature of the food after 2 hours, then I can find the number of bacteria. Well, I've already combined these equations, so I can just use that one that I already found, which is 320, and then T is 2 squared plus 420, which is 2 squared is 4. 4 times 320 is 1280. So 1280 plus 420, and I get 1700 bacteria. Gross, right? Icky. Okay, and then the last one is find the time. So find T when the bacteria count reaches 2000. So now I'm working backwards, right? I have this equation, 2000, and I want to know what is T. I want to know how many hours has it been out before it reaches that 2000 bacteria mark. So I'm just going to solve. Subtract 420, so I get 1580. And math just got real weird. 1580 equals 320 t squared, right? Divide by 320, and I get about 4.9375 equals t squared. And I'm going to leave that 4.9375 on my calculator so I can just use second square root, second answer, and I don't have to type in this number because then I'll be rounding. Okay, so you try to use the exact number when you can. So I get T is about 2.22 hours, right? And I could figure out really how long that is, right? 0.22 hours. Well, and there's 1 hour is 60 minutes. So if I multiply that, of course, that's one I don't have done. So if you take your calculator and you multiply 0.22 times 60, I get 13.2. So 2 hours and about 13 minutes. 2 hours, 13 minutes. Or I'm okay if you just leave it 2.22 hours. That's fine as well. Okay, so that's it for 1.5. Let me know if you have any questions. Reach out to me. Otherwise, I will see you in the next video when we talk about inverses.